Okay, good evening everyone. Can you hear me? Can anyone please confirm? Hello, are you people able to hear me? Someone can. Yeah, okay. So, yeah, we'll start our class to now. It's already 7:10 and we can add when others join. So, I am Vishal Dhar. So, I am a Prime Minister Research Fellow from IIT Guwahati. I am working under Professor Pankaj Tiwari sir from Department of Chemical Engineering IIT Guwahati. So today we will be doing our first live session. The course is Petroleum Reservoir Engineering, and today we'll be solving first week assignment. Okay, so before starting the first week assignment, that is from previous year, that is 2023. I will be solving the assignment so that you can relate these assignments with your current year and do the assignments from by yourselves. Okay, so yeah, first we'll go through a quick revision of first week contents. So okay, if in between, if you have any doubt, if you have any query, you can just turn on your mic and ask me the questions and I will answer, because when I am in the presentation slide, I can't check this Google Meet window. So it's better if you just can unmute yourself and ask me questions. Okay, and if you are not hearing or not able to see the slides, do let me know. So yeah, for first with a quick revision of week 1 contents. What is reservoir? Reservoir is a porous and permeable lithological unit or set of units that holds the hydrocarbon reserves. Porous and permeable. You have gone through the classes. You have any idea what is porosity and permeability? Anyone? Anyone can tell me what is any idea of porosity and permeability? This is the two basic concepts of petroleum engineering. So very important to understand these two factors. What is porosity and what is permeability? Anyone?
Yes, sir. I am Vishal.
Okay.
Porosity, porosity is the wide space in a reservoir or a reservoir rock. It basically tells about amount of hydrocarbon fluid that may be stored there.
Yes.
Whereas this permeability is defined as it may be explained as the interconnectivity between the pores. If the pores are interconnected, then we say that is permeable.
Yes, Vishal, very good. Yeah, your answer is absolutely correct. Let me just elaborate a little on this. So, yeah, so the porosity is the, yes, as Vishal, as he said, so porosity is the void space in the reservoir rocks. The reservoir rocks, which is the underground rocks, these are not fully made of solid. There are gaps in between. There are small pores in between the rocks. These pore spaces that make up the rock structure is called the porosity of that rock. In generally, the reservoir rocks, they have a porosity of 10 to 20, 10 to 30, 10 to 30%. 10 to 30% means if we take 1 unit of rock particle, then 10% of that rock particle will be void and other 90% will be solid matrix. So yeah, so the pores make up the porosity of the rock. The total pore volume makes the porosity of the rock. The hydrocarbon are stored in these pore spaces. The crude oil that we get, crude oil or gas or whatever whatever petroleum products are there, that is stored in these pores of the rocks. And permeability, you can say, as Vishal explained, it is the interconnection of the spores. The permeability you can also say in a way that it is the path through which the fluid flows. The some of the pores are also, there are some of the pores which are not connected to any other pores. Again, there are some pores which are connected to other pores. These connection of the pores is the, you can say, the say can be defined by a term called permeability. The more the permeability of the rock, the more is the more the liquid can flow through this rock. So yes, the porosity and permeability are two main concepts in reservoir engineering. So this reservoir, this can be of conventional and unconventional type. Conventional reservoirs are having are these reservoirs which have a permeability of around 100 to 1000 millidarcy. Permeability is measured in millidarcy. Porosity is measured in percentage, and permeability in darcy or millidarcy. In field units, it is mainly measured in millidarcy. So above 100, we can say it is conventional. Above 100 or above 50. But when the porosity permeability is very less, it is in the range of zero point 0.1 to 1 millidarcy, or zero point 0.1 to zero point 0.5 millidarcy, then it is called unconventional reservoirs. You can check the range. My range may not be exact, but it lies in the range of, means when the permeability is very less, when it is in 0.1, 0.01, or zero point 0.5, it is called unconventional reservoirs. And when the permeability is more, when it is more than 50, more than 100, we call it conventional reservoirs. These are the topics you have already done in your NPTEL classes. So I will just go through the basic. I won't go into elaborate detail. And if you have any question, you can ask me in between. So yeah, let's continue. So what are the types of oil reservoir? Oil reservoirs are of three types. The unsaturated oil reservoir, then there is saturated oil reservoir, then there are gas cap reservoirs. What is unsaturated oil reservoirs? Unsaturated oil reservoirs are unsaturated oil reservoir. There is a pressure in this all the reservoirs. They are at a particular pressure and temperature. So means these reservoirs are underground. They are deep under the earth crust. So at this depth, there is a pressure and temperature acting on these reservoirs. So when the pressure is in this pressure range, we can there is a point called bubble point pressure. Bubble point pressure is the point where if the reservoir pressure goes under bubble point pressure, the gas starts to come out of the oil. So that point where the gas comes to come out of the oil is called the bubble point pressure. So when our reservoir is above the bubble point pressure, it is called undersaturated oil reservoirs, and when it is below the bubble point pressure, it is called saturated oil reservoir. Saturated oil reservoir, this can also be called as gap cap reservoir. In this I have uh, made it another means I have used another term called gas cap reservoir. Gas cap reservoir is mainly a reservoir which when we have discovered the reservoir is already below the bubble point pressure. In that case, the gas has already escaped from some of the gas has already escaped from the oil and is occupying the space uh, above the crude oil, above the oil. So these are the gas cap reservoirs. So next is the type of gas reservoirs. Gas reservoirs are dry gas reservoirs, wet gas reservoir, condensate reservoir. These are the three types of gas reservoirs. Dry gas reservoirs are those reservoirs when while we are taking out the what happens while we are taking out the gas, when the gas comes at the surface, the pressure and temperature comes down at the surface. When it is at the depth, the pressure and temperature is very high, but when at the surface, the pressure and temperature comes out at normal standard pressure and temperature, which is 14.7 psi for pressure, and for temperature it is 60 degrees Celsius. So at this pressure temperature, some liquid tries to condense out from the gas. When the reservoir is the reservoir which is dry gas, this type of reservoir, from this type of reservoir, no liquid will condense out. There will be gas when they are at the bottom, and also it will be gas when they we have extracted them and we have kept this gas in the reservoir. Wet gas is when there is when the gas is means is when the fluid is in the gaseous state in the reservoir, but at the separator some of the gas condenses out, some of the liquid condense out from the gas. So this type of reservoirs are called wet gate reservoir. Condensate reservoirs are those when there is a interchange between gaseous and fluid state in the reservoir itself. In the reservoir itself, some of the oil condense out from the gas and it's stuck in the reservoir. So this is called condensate reservoir. Condensate reservoirs are little difficult to handle. The production is little lower in the condensate reservoir unless we use efficient technologies. Next is gas oil ratio. Gas oil ratio can be defined as the amount of gas that is released from per unit of oil. In field unit we call it STB. STB means standard STB is standard barrel. Standard barrel means when we are doing the measurements at the surface, we call it standard barrel. When we are doing the same measurement at the reservoir condition, we call it reservoir barrel. So these gas wells, they have a high amount of gas in the means gas reservoirs. They have high amount of gas present. So the GOR is means more than 100,000 SCF per STB. SCF is standard cubic feet plus standard barrel. Then condensate reservoir, the gas oil ratio lies between 5,000 to 100,000 SCF per STB. Oil well, they have lesser gas present in them. So the gas oil ratio is 500 SCF per 5,000 SCF per STB. 5,000 SCF per STB means from 5,000 standard cubic feet of gas is released from one standard barrel of oil. So 5,000 SCF per STB means 5,000 standard cubic feet of oil gas is released is from 1 STB of oil. So this is the definition for gas oil ratio. API gravity can be linked. This is a term that is used in the petroleum industry to define how heavy or light our crude is. When our crude is very heavy, the API ranges from 0 degree to 20 degree API. When the crude is in the medium range, then the API ranges from 20 to 30 degrees, sometimes 35 degree API. And when the crude is very light, the when the crude is light on the lighter end, the API ranges above 30 degree API. 30 degree API, it can be 45-50 degree API is very light crude oil. This API can be related to specific gravity, which can be related to the density of your fluid. So in a way, it tells us how dense our crude is. Next is next is reservoir fluid. The fluids that are present in the reservoir are crude oil, natural gas, and formation water. These three are the fluids that are present in the reservoir. Then a typical petroleum reservoir consists of a source rock. Source rock is the rock in which crude oil is originated. Crude oil is formed from kerosene. See, I'm telling you, I won't get into the details because I need to solve questions. So if you have any question, you can ask in between and I will just touch the main. Can you see my screen now? Someone is asking me to share my screen. Can you just anyone unmute yourself and let me know if you are able to see the screen?
No, I also cannot see your screen, sir.
You are not being able to see the screen.
No, no.
Can you see the screen now?
No, not yet.
Not yet. Okay. Can other just tell me if others can see my screen? Everyone. No, that's okay. No one. Just then let me do one thing. Let me stop this and start again. Can you see my screen now?
Yes, yes. Now you can see.
Now it's visible, right? Okay, so just let me go to the previous slide once again, as my screen wasn't visible. So yeah, so also for the people who have joined after some time. So yeah, so I am Vishal Dhar. I am a Prime Minister Research Fellow in IIT Guwahati, and my the course tutor for this subject is Professor Pankaj Tiwari. He is also from Department of Chemical Engineering, IIT Guwahati. The course is Petroleum Reservoir Engineering, and today we will be solving week 1 assignment from previous year, that is 2023. So first I will go with quick revision of week 1 contents that you have studied this in first week, and then we will be solving the question. I won't be going into details because that is already covered in your class. I will just go through some of the basics so that it's for a brush up before we do the assignment questions. So I have already told the concepts of porosity and permeability. So what is reservoir? I have already said it is a porous and permeable lithological unit or set of units that holds the hydrocarbon reserves. So the porosity and permeability are very important two concepts in reservoir engineering. Porosity is the amount of pores that is present in a unit of rock. If we say the porosity is 10%, means if I take a unit of rock, then 10% of this rock is void space and remaining 90% is solid matrix. Then again, um, permeability is the connection of pores. You can say in one way how the pores are connected, and it also gives us an idea about the fluid flow, the area through which fluid flows in the reservoir. Then there are types of reservoir: conventional and unconventional. Conventional reservoirs are those which have very high porosity, which have very high permeability in the range above 100. It can go to up to 500 and 1000. And unconventional reservoirs are these are having very low permeability, that is in the range of zero point 0.1, zero point 0.5 or zero point 0.01 also in some cases. Then there are types of oil reservoir. Oil reservoirs are mainly of two types: undersaturated and saturated oil reservoirs. This type of reservoir can be defined by a particular pressure point, that is called the bubble point pressure. Bubble point pressure is the pressure at which the first drop of gas, bubble point pressure is the pressure at which the first bubble of gas comes out of the liquid. So at in the reservoir, if the pressure is above the bubble point, then there is no gas in this reservoir. But in those reservoir where the pressure is below the bubble point, there will be associated gas in the reservoir called the gas cap. So if initially when you discover the reservoir, our reservoir is below the bubble point, then it is called gas cap reservoir. It is a type of saturated oil reservoir. This gas cap reservoir, you can say in means in there you can take it as a third type of reservoir, or can just say it's a type of saturated oil reservoir, gas reservoirs. Then there are type of gas reservoirs in which there is no liquid present. There is dry gas reservoir, there is wet gas reservoir, and there are condensate reservoirs. Dry gas reservoirs Dry gas reservoirs are those reservoirs in which at reservoir condition the reservoir is at gaseous state. Again at the surface condition, means at the separator condition, when the pressure and temperature has reduced, the gas there is no liquid that condense out from the gas, and the reservoir is at dry gas state only. Wet gas reservoirs are those reservoirs in which the reservoir is at gaseous state in the reservoir condition, that is at high pressure and temperature, but at the surface condition, that is at normal pressure temperature, which is 14.7 psi for pressure and 60 degrees Celsius for temperature. In that case, some of the liquid condense out, means in separator we get some oil. Condensate reservoirs are those reservoirs in which they are interchanged, means the in liquid condense out from the gas at the reservoir condition itself. These are little means difficult to handle, the condensate reservoirs, because the liquid condense out and the liquid condense out from gas at the reservoir condition itself and get stuck. So we need some effective technology for handling condensate reservoirs. Then the next term that I was explaining was gas oil ratio. Gas oil ratio is the amount of gas present in part stock tank barrel of, it can be called standard barrel or stock tank barrel of oil. Stock tank barrel uh, is the unit that we use at the surface condition, and at reservoir condition we use the unit reservoir barrel, RB. Means at high pressure temperature we use the volume as RB, and at surface condition, when the pressure is at normal pressure temperature, uh, we use STB, stock tank barrel or standard barrel. So the for gas oil, the GOR is more than 100,000 SCF per STB, means 100,000 cubic feet of gas can is released from one stock tank barrel of oil. For condensate, the range is between 5,000 to 100,000. For oil well, the range is less than 5,000. For oil well, the 5,000 standard cubic feet of oil per STB, standard cubic feet of gas is released per STB of oil, means less than that. Again, there is a term called API gravity. It is used in petroleum engineering. API gravity is a term used to tell us how heavier or lighter our crude is. In a way, it tells about the density, because API gravity can be related to specific gravity, which can again be related to densities. So heavy crude have API gravity of 0 to 20 degree API. For medium crude, it is 20 to 30 degree API, and for lighter crude, it is more than 30 degree API. Means the numerical value is inversely proportional to the heaviness of the crude. So we come to the next slide. What are the fluids that are present in the reservoir? This is mainly crude oil, natural gas, and formation water. So I, I won't tell I won't go into detail what are these, because you have already studied in your class. So these are the three components that are present in the reservoir fluid. Next is the typical petroleum reservoir consists of a source rock, a reservoir rock, and a cap rock. Source rock, you can say the rock in which the petroleum is formed. Petroleum is mainly formed is source rock. These are mainly clay, and means these are mainly sedimentary rocks. And after forming in source rock, with pressure and temperature, this liquid get expelled. These petroleum fluids get expelled, and they move from one place to another. This migration continues unless they get a cap rock, which is again shale. This is a type of clay, hard clay, shale. Shale, shale is a type of cap rock. It is called cap rock because the permeability of shale is very less. So the amount of fluid that goes into shale when there is a shale in between in the path of the reservoir, in the part of the reservoir fluid, that fluid cannot travel anymore, and they gets accumulated in that part. Yeah, so they get accumulated in that part. So in that the part where the reservoir fluid gets accumulated is called the reservoir rock. This is also sedimentary rock. When we are talking about petroleum, we mainly deal with sedimentary rocks, not igneous, not metamorphic. We mainly deal with the sedimentary rocks. So these are the source rock, reservoir rock, and cap rock. Next is the fluid types in reservoir. The fluid in the reservoir can be distinguished into three main types. These are incompressible fluids, slightly compressible fluids, and compressible fluids. Incompressible fluid, that is mainly while we are doing the equations and numerical, we take water as the incompressible fluid. Slightly compressible, when we talk about crude oil, uh, we take it as slightly compressible fluid, and gas we take it as a compressible fluid. Next is flow regimes. Flow regimes are steady state flow, then there is unsteady state flow, then there is pseudo steady state flow. When the mm, steady state, just give me 1 second.
Sir, is formation water compressible or non-compressible?
Formation
Like
water.
slightly compressible or
Yeah, actually,
incompressible
this
fluids?
formation water is slightly compressible, but it is very less compressible. Means the it is less compressible than oil. So while doing our numericals and in petroleum industry, we take water as non-compressible in maximum of the cases. But yes, you can tell it is very slightly compressible water, formation water. Just give me 1 second. Yeah, okay. Yeah. Are you able to hear me now? Okay, so let me start. Okay, so the flow regimes are steady state, unsteady state, and pseudo steady state. This is mainly in steady state, the pressure is constant with time. In unsteady state, the pressure decreases with time, and in pseudo steady state, the pressure is a function of the distance. So I won't go into these details. It will take much time because I need to solve the equation also, and hopefully you have done all this in your classes. Next, we'll continue to reservoir geometry. Reservoir geometry is the you can tell the how the fluid flow into the wells. So there are four types of flow: the radial flow, then there is linear flow, or spherical flow, and hemispherical flow. In our reservoir engineering, we mainly deal with linear flow and radial flow, and the Darcy equation is also modified for this type of flow. So then there are again flowing phases. There can be a single phase, means only oil or water or gas is flowing. Then there are double phase where oil and water are flowing together, or oil or gas is flowing together, or gas and water is flowing together. Then there is three phase flow in which oil, gas, and water, um, three of the phases are flowing together. Then we come to the Darcy law. The main equation that is used in petroleum industry is Darcy law. For linear flow, it is permeability into density into d phi is the means it is a function of pressure with distance, and mu is the viscosity. For radial flow, the equation is same. Only the pressure here is is a function of radius and not linear distance. The assumptions in Darcy law, while we will be going with the equation, I will go more into the Darcy law and I will explain it in a better way. And now we are just having a recap of what you have done in your class. So as the assumptions that are used in Darcy law are mainly the flow is laminar, the flow is steady state flow, the fluid is incompressible, and the reservoir is a homogeneous reservoir. Again, there are many changes that is done in the Darcy law to remove the assumptions. Like if here the equation that is given, for that is mainly for incompressible fluid, but there are equations for slightly compressible fluid, for both for linear and radial flow, and there are equations for gaseous flow also, that is compressible fluids also, that is mainly gas reservoirs. Next, we'll be seeing the units that we'll be using mainly in our course. That is length, mass, time, velocity, rate of flow, pressure, density, viscosity. Just have a quick look. I won't go into detail. Today, anyway, we don't have much numerical related to reservoir engineering. In next class, maybe we'll be having numericals. So we'll be using the units at that time mainly. Next is the variables used in petroleum industries area. In field unit, we use acre. In SI, it is meter square. Meter square. The conversion rate is, or the conversion value is also given. For compressibility is pressure inverse. On SI unit is Pascal inverse. For length, feet meter. Permeability millidarcy. In field unit, the unit that you are seeing on the left side means the US field unit. These are the main units that we'll be dealing with in our course. So it is very important to know the conversion factors, the conversion values for each of these units. Then for pressure, it is PSI, SI unit is Pascal. For rate is HTB per day, that is stock tank barrel per day. It can be reservoir barrel also, which then for SI unit is meter cube per second. For gas rate is MSC per day, that is million standard cubic feet per day. Then for viscosity, centipoise or Pascal second. Then there are two mathematical equation means formulas that we use in our that are sometimes required in petroleum industry. This is the trapezoidal rule and Newton-Raphson rule from numerical methods. So these are the formulas here are given. We'll be doing one or two numericals based on this today. So you can just see the formulas or note it down if you want, so that while doing the numericals it is easy for you to solve. And next, if you are writing the number, I am giving you 2 minutes, 1 minute, you can just write down the formulas. Can you see the slides now? Okay, hopefully you can see the slides. Then write down the equation, then we'll go to the next. If you have any question, just unmute yourself and ask, because whenever I change the window, the slides disappear. Okay, let me go to the next slide. So, what is petroleum reserve? Petroleum reserve, here you can see the petroleum reserves in a way is how much oil is present in the reservoir. How much original oil in place is present in the reservoir. It can again be classified into recoverable reserves and unrecoverable reserves. As you can see, the original oil that is present, from there only 34% of the oil can be is recoverable through primary production. Again, there are techniques through which we can also recover the some percentage of the unrecoverable oils. These are means these methods are used. These methods are called enhanced oil recovery methods. So we'll go to those topics in the later part of our course. So for now, this original oil in place, they can be. This is the reserve present in from original oil in place. 34% is recoverable reserves. Unrecoverable is 66%. Again, recoverable can be classified into proved, probable, and possible reserves. Proved reserves are those which has been proved to be means the reserve that we can take out at this point of time. Means when we are talking, this amount of oil can be produced. These are the recoverable. These are the proved reserve. Probable reserves. These are mainly the reserves which can be taken out in future using advanced technique. And possible reserves are those reserves which means through geological survey and all we have found out that this amount of reserve is present, but we still are very there is a very still vague idea about the percentage and also how much can be recoverable from that. In from proved reserve, then there are two types, that is developed and underdeveloped reserve. Developed reserves are those which we have already means drilled a well and we are recovering, which through which we have already means drilled a well and we have used put the production casing and the put the well into production. These are the developed wells. And then there are undeveloped, which we know there is present, but we have not yet exploited those reserves. From developed also, some wells are producing, some wells are non-producing. Producing wells are those wells which whenever we start the well, the oil starts flowing immediately. Non-producing are those wells which has some problem and we have to mitigate those problem to take out the oil from the reservoirs. Next we'll go to the composition of the petroleum. So petroleum composition is mainly hydrocarbon, in which carbon is 84 to 86%, hydrogen is 11 to 14%, oxygen and other substances like oxygen, nitrogen, and sulfur they are about 8%. There are two theories of origin of petroleum: organic and inorganic theory. I won't go to the theories; these are already done in your class. For fluid hydrogen, they can be again the fluid hydrogen is the main aim of our this course of our petroleum industry. The this can be classified into liquid hydrocarbons and natural gas. Liquid hydrocarbons can again be classified into crude oil and natural gas liquid. Natural gas liquid can again be classified into condensate, gasoline, and LPG. In natural gas, there are non-associated gas. Non-associated gas are those gas which is present in the reservoirs in which no oil is present, only gas is present, is called non-associated gas. Means during discovery there is no oil present, only gas is present. So these are non-associated gas. Associated gas means the reservoir is under the bubble point pressure and there is oil present in the reservoir, and with oil there is a amount of gas is also present in the reservoir. These are called the associated gas. Dissolved gas is the gas which at the time of discovery is dissolved in the oil, which when we start production from those wells and the pressure goes down, this dissolved gas will come out from the oil eventually. Next, for some general knowledge, but we have this OPEC. OPEC is Organization of Petroleum Exporting Countries. There are 13 countries in OPEC. and it was founded in 1960 in Baghdad. At that time, I think 5 countries were there during OPEC formation. Then its headquarters is in Vienna, and it was formed in 1965. The headquarters in Vienna was established in 1965. Then there is a country called Venezuela which has the highest oil reserve. Though its petroleum production is not the highest, but it oil reserve it has in the sector of oil reserve it has the highest oil reserves. And coming to India, India ranks third in world in oil consumption. The India's oil consumption is 4.6% of the world's total consumption. Then Indian wells are as deep as 12,000 feet and can yield as small as 200 barrel per day to as high as 3,000 barrel per day. Again, we come to crude oil composition. Mainly, it can be divided into many hydrocarbon groups are present in crude oil. These are paraffins, cyclopentenes, cyclohexanes, cycloheptanes, dicycloparaffins, benzenes, aromatic cycloparaffins, dinuclear and polynuclear aromatics. I won't go into details. And next we come to we can classify this composition into broad classification. Then these are in broadly this can be classified into 3 types: open chain or aliphatic compounds. In this there are mainly N-paraffin series or isoparaffin series. These are long chain hydrocarbons. These are not cyclic hydrocarbons. These are just long chain hydrocarbons. Then there are ring or cyclic hydrocarbons. These are naphthalene series or cycloparaffins or aromatic or benzene series. Then there are asphalts and resins. These are very heavy petroleum products. Then there is it can also be classified as hydrocarbons having paraffin base, which means they have predominantly open chain compounds like long chain with low grade gasoline. They give us low grade gasoline, waxy lube oil. Then there is naphthalene base. This mainly gives us cyclic compounds, mainly asphaltene. Indian crude is mainly of naphthalene base. Then there is intermediate base. The large quantities of both paraffinic and naphthenic compounds are present. This, yeah, hello. Any question? Yeah, anyone, any question? Okay, then let me go to the slides again. Next will be types of rocks. So mainly igneous, metamorphic and sedimentary rocks are present. Igneous rocks are granite, basalt and gabbro. Metamorphic rocks are slate, marble, schist. Then sedimentary rocks are limestone, sandstone, clay. These are the types of rock and these are some of the examples of the types of rocks. And mainly while we are talking about petroleum, we deal with sedimentary rocks. In sedimentary rocks, there are sandstone, then there are carbonate, and in carbonate there can be limestone also, there can be dolomite also. Next is shale, and fourth is evaporite. So next is migration. Migration is can be divided into 3 types. Primary migration is when petroleum is or crude oil is expelled from fine grained source rock. When the organic matter under heavy pressure and temperature liberates crude in the source rock, it is called primary migration. Next is secondary migration, when this petroleum moves through a coarse grain carrier bed or fault to a reservoir. Means when this secondary migration happens, when this petroleum moves from the source rock to the reservoir rock, I mainly told you, when you find a, when the reservoir, due to high pressure and temperature, these petroleum products are expelled from the source rock, and they keeps on traveling underneath the earth's surface, and they stop traveling when they get a hindrance in their way, means there is a blockage in their way. This blockage is provided by the cap rock, which is mainly shale, which is mainly shale. These cap rocks, these cap rocks have very low permeability, so oil cannot pass through these rocks. They can pass, but very little. Means the uh, output is very less than input. The amount of oil that is coming on to the cap rock is much more than the oil that is getting expelled from the cap rock. So the oil gets accumulated in this area. Then there is tertiary migration, when petroleum moves can move from one trap to another or to a ship. Means also I told you the migration is very less, but there are little migration through the small pores, and some of the liquid gets out from the cap rock, and some in some cases they can also come to the surface. Ship means when the crude oil comes at the surface. There are some places where you can see crude oil at the surface without any drilling wells or without doing anything. You can just see little bit of crude oil coming out at the surface. If you go to the YouTube and search examples of petroleum ships, then you can see the in world where the petroleum ships are present. We are talking about the traps or the caps rock. Then traps can be of different types. There are mainly two types. These are structural trap and stratigraphic traps. Structural traps are mainly anticline, syncline, fold, fault, salt dome. Stratigraphic trap are lances, unconformity, pinch out, porosity trap. I won't go into the detailed structure of all this because we have this assignment to do, and if we go into detail, it will take our whole class time. You can just say when there is a this anticline, syncline, fold, fault, lances, unconformity, these can all be find out through geological and geophysical surveys. In through geological surveys, or also while you can see the surface of the earth crust, and geologists, not any common people, the geologists, they can identify the structure underneath by seeing the surface, seeing the structure at the surface. So fold, fault, anticline, syncline, these are some of the structure that can be seen at the surface itself if you know how to identify them. So these are the places where there are the maximum chances of finding a reservoir, because these are the traps which blocks the path of the petroleum flowing underneath. Then there is geological time scale. It is the system of chronological dating that really relates to geological strata or time. In normal layman language, we can say that it is a periodic table of the strata. When which layer of rock was formed, we can see the geological time scale and we can identify. Then the organic matter, they need organic matter that is deposited. I hope everybody knows that the organic matter, how this petroleum is formed. It is formed from the theory that we follow mainly is that that the petroleum is formed from fossil fuels. Fossil fuels, they get deposited underneath earth crust for years. They remain deposited, and with years they get buried underneath, and layers of deposition, layers of rocks get deposited above. So with time, the depth of their deposition gets uh, increased. So with time, they get more and more underneath the earth surface, and the pressure and temperature builds up when the fossil fuels are gets buried deep underneath. With time, the pressure and temperature builds up, and this pressure and temperature leads to the formation of organic matter. And with organic matter, this leads to the formation of kerosene. Kerosene is a means product. What I what how I say it. It is a before product of petroleum, in way you can say, means before after petroleum is formed from kerosene, it's kerosene only. So kerosene has the organic matter in them. So these are some of the experiments or some of the analysis that you can do to find out how much the organic matter has matured. So these are vitrinal reflectance, pyrolysis, rock eval pyrolysis, and biomarkers. I won't go in detail into the analysis. Next is the types of drilling rigs. In the fourth class, I guess you have studied about the drilling. So one quick recap of the drilling. Just anyone, do you have any question till now? Anything you want to ask? Any? Okay. So my voice is clear and you are able to see the slides, right? Till now?
Yes, sir.
Okay. Okay, thank you. So I will continue. Next is drilling rigs. Drilling rigs are mainly of land rigs or offshore rigs. Offshore rigs, they are again of many types: drill ships, semi-submersible, jack-up rigs, drilling barges. These types of rigs, offshore rigs, are differentiated on the depth at which they are operating. Drill ships, semi-submersible, jack-up, and drill rigs, they all have different depths of operation. Then there are the main type of drilling that we are use in our petroleum industry is roller cone drilling system, rotary drilling system in which we use roller cone bits and drag bits and sometimes drag bits also. Drag bits is mainly used where the soil is very hard and sticky. Roller cone bits are used for medium to hard type of rocks, cutting medium to hard type of rocks. In drag beads we use diamond beads at the front of those beads, and roller cone has tungsten carbide materials inserted in them. These are some of the materials that cutting materials that are inserted in those beads. Roller cone beads are mainly three cone system. There are three cones that are rotating simultaneously. Next is the circulatory system. Circulatory system is mainly the circulation of the drilling fluid, which is the drilling mud. Drilling mud is one of the very important aspect of drilling. We won't go into much detail because it's just a means overview of all the systems, so that while going through the course you don't find any confusion. This is mainly covered in drilling engineering subject. In reservoir engineering, we just have a means overview of all this. So drilling mud, what is drilling mud? It is a fluid, mostly it is a most commonly a suspension of clay and other in water. Mud is mainly clay and there are many materials that are used in mainly there are weight building agents are used, weight reducing agents are used, then again corrosion inhibitors are used. So these are other components that are used in the drilling mud. So the main components of the circulatory systems are mud pumps, pits, mud mixing equipment, and containment removal equipment. I won't go into the details again. Then there is well casing. Well casing, different types of casing are used. Conductor casing. First is conductor casing, that is used just after drilling 50-meter or 40-meter of hole. Then there is surface casing. Inside conductor casing you use surface casing. Then there is intermediate casing. The intermediate casing is the long strand of casing. The longest strand of casing you can say. Then there is production casing, that is the last casing through which the production is done. And again in some cases liners are also used inside production casing, in some cases. So these casings, why they are mainly used? They are mainly used so that the area that we have drilled, when after drilling a hole, if we leave the hole open, the surface will again converge, and this hole will be filled out with the soil in soil surrounding the hole. So we need to make sure the soil doesn't converge and block the hole. So after drilling a certain amount of depth, we place the casings. These are hollow cylinder type materials which have very means high depth, you can say, and these are cemented with the soil present at the cemented with the soil or the surface present. Then there is rotary drilling rig system, in which we have the power system. Rotary drilling rig, we I told you, mainly in today's generation we mainly use rotary drilling system. In rotary drilling system we have the power system, hoisting system, fluid circulatory system, that is the mud system that I have already told you. Hoisting system is the means lifting up of the drill string and drill pipe. Then rotary system is the system that is used to um, move the drill pipe inside. Drill pipe is rotated so that the beads are rotated at their end, which enables the drilling and cutting of the rock surfaces. Then there is oil control system. It is also called the blowout preventer system. It is mainly used to control the uncontrollable fluid and gas when they are ejected from the wells. This is one of the most important system in the This is one of the most important system for the safety of the operators. Next is oil monitoring system. This system is used for monitoring the pressure and temperature at all conditions. Then there is cementing system. I already told you the casing needs to be cemented with the surface around it. So for that we use cementing system. Cementing can be done in single stage and double stage. I won't go into these details. Here is a phase diagram just for your, you can see the pressure temperature diagram of a single point system. There is the critical point. Above the critical point, the fluid acts as a supercritical fluid. Supercritical fluid that it neither acts as a pure liquid, neither it acts as a pure gas. The phase is somewhere in between. Below this critical point, in the left side there is liquid phase. In the right side this is gaseous phase. Then there is a solid phase also at the left corner. And if we come to the two phase system, you can see the bubble point curve and the dew point curve. Everything below the this is a pressure temperature diagram. And you can take any point. You can see my arrow. If my arrow, you can see it is inside this curve of that is made by bubble point and dew point. Means at this pressure and temperature, the fluid that is existing is in two stage. Means if a reservoir, let me give an example of the reservoir. If a reservoir is at this pressure and temperature where my arrow is pointing, then that reservoir is in that reservoir liquid is also present, gas is also present. The liquid present may be 85%, because it is, you can see the point is above 80%, and the 15% may be gas. As we go down, or as we go on the right side, you can see the 80%, 60%. This is the amount of liquid present in the two phase region. As we go from left to right, you can see the amount of liquid is decreasing, or also when we are going from top to bottom, also the amount of liquid is decreasing. First it was 80%. As we go down, it is 60%. As we go out, it is 40%. 40% means 40% liquid and 60% gas. Then there is 20%, and at the dew point, the liquid is, the last drop of liquid evaporates. Means when my point is on the curve, then you can say that at this point the last drop of liquid that was present in the reservoir has evaporated. If we go further, this means if we decrease the pressure further and increase the temperature more, then you will see, we will find only gas is present in the reservoir. And there is a point called Crickondon thumb. Crickondon thumb is the maximum temperature at which this liquid can be present. Above this temperature, no liquid can be present. Pre-condensed bar. Just give me 1 second. Let me see if I can find something to explain in more detail. Yeah, this is the explanation given everywhere. So, pre-condensed therm is the maximum temperature at which liquid and gas can coexist. Similarly, pre-condensed bar is the means highest pressure at which the liquid and gas can exist together. So, next is gas condensate reservoir. These are I will go to explain all this when we come to this topic in the next 2-3 sessions. Let me not go because it's already 8:13 and let us start doing the assignments now. So here I need you all to answer the questions. Can you see the question in the question in the slide? The first question is which of the following is a stratigraphic trap? Example is anticline. Example B is fault trap. Option C is angular conformity trap and option D is lenticular trap. Anyone please answer?
Sir, is it angular unconformity trap?
Angular unconformity trap. Okay. Anyone else? Anyone else wants to answer? Okay. The Umut sir has said option C. And okay. So yeah, the correct option is Sheetal also said option C. Yeah, the correct option is angular unconformity trap.
Sir, but won't D also be the right option? I mean, lens is almost is like a lenticular trap, right?
Lenticular trap. Just 1 second. Check. Lenticular Yeah, actually lenticular trap, it is actually a combination of stratigraphic trap and structural trap. So if we are talking only of stratigraphic trap, then it's angular unconformity trap. Okay,
Okay, sir. Okay.
lenticular trap comes under structural and stratigraphic both. It is a combination trap. Next question is, the CO2 generated during the rock eval pyrolysis is recorded as option 1. Option A is S1 peak, option 2 is S2 peak, option 3 is S3 peak, and option 4 is S4 peak. These are direct theoretical questions from your classes that was done previous year. So you can go through your notes also and answer if you have written down the notes.
Sir, S3 peak.
Yeah, who is saying this? Avani. Okay, Avani.
Yes, sir.
Yeah, S3 peak. Anyone else? Okay, just tell me one thing. When I'm in this window, can you see my slides now, or it's not visible now?
We can see the slides, sir.
Okay, okay, okay. Okay, then anyone else? Okay, thank you, Sheetal. Yeah, so Avani has answered S3 peak, option C. Anyone else? Okay, so yeah, the option is option C, S3 peak. These are theoretical questions. This you have already done your class, so I am not going into detail and explanation. And whenever there is a numerical or something, we can discuss. If you have any question, you can ask me anyway. So the next question is, the percent TOC can be used. TOC, can anyone tell me the full form of TOC? Anyone?
Sir, total organic carbon.
Yeah, total organic carbon.
Percentage total organic carbon.
Yes. So the TOC is TOC is percentage of total organic carbon. So as I have already shown you in previous slides that there are uh, various analysis to find the maturity of the organic compound. So percent TOC is one of those. So the percent TOC can be calculated using the formula option A. Uh, TOC equal to 0.082 S1 plus S2 plus S4 divided by 10. See, S1, S2, S4, these are the peaks that we get from rock eval pyrolysis. Okay. So next option is percent TOC equal to 0.082 S1 plus S3 plus 0.082 whole thing S1 plus S2 bracket close plus S4 divided by 10. Option 3 is 0.082 whole thing S2 plus S3 bracket close plus S4 divided by 10. And option D is 0.082 S1 plus S4 in bracket plus S4 divided by 10. Any guesses?
The option is A.
Option is A. Yeah. Who's this?
Sayed.
Sayed. Okay, you are saying option is A. Anyone else? Okay, you said you are correct. The option is A. We will go to the next question. So the next question is, what of the following is a major function of a drilling mud? Option A is provide lubrication to the drilling bit. Next is stabilization of the wellbore wall. Option C is prevention of corrosion of the drill bit. And option D is none of the above.
Sir, stabilization of the well bore wall.
Yes. The anyone else?
Sir, A and B.
A and B.
Yes, sir.
See, the options are here little confusing. Who is this? Who said A and B?
Me, Vishal,
Vishal.
sir.
Okay. So yeah, you are partially correct. Yeah, you are partially correct. The option,
Sir, one of the major function of drilling fluid is this lubrication to drill bit and stabilization of well
yes,
bore.
the
And I am
see,
not sure about
yeah,
sure about corrosion. But
yeah,
these two A and B both should be right.
yes, yes. Actually, see here what they have done. The correct answer is given stabilization of the wellbore wall, which is one of the main function. Why provide lubrication to the drill bit is not given because what drilling fluid its main function is providing lubrication and corrosion control to the drill sting, not actually the drill bit. Yes, the lubrication means providing lubricating the drill bit is also done in the process, but the main function of the drilling mud is providing lubrication to the drill sting mainly, and the this lubrication to the drill sting and providing corrosion control to the drill sting. If there was an option here for A and B, you could have marked A and B, but since here is no such options, so the correct option in this case will be stabilization of the wellbore wall, because in this case it is a correct answer with no, means no doubt. In A or C there is little bit of doubt because it's talking about the drill bit and not the drill stem. And whenever you see the function of the drill sting, you will see it doesn't mention about the drill bit, it mainly mention about the drill stem. Drill stem, if anyone doesn't know, is the drilling string that comes that means that starts from the surface of the rig to inside the drill inside the drilling well and to the point where we are drilling. So yeah, so yes, Vishal, your answer is also not, I won't say it's wrong, but there, since there is no option as such, so we'll be going with the stabilization of the drill wheel wall. Okay.
Okay, sir.
So yeah, next question is so now we here we get a numerical. The use the Newton-Raphson method. It will be e to the power. This one will be e to the power minus x. So use Newton-Raphson method to estimate the root of function e to the power minus x, employing an initial guess for s0 equal to 0. And the options are option A is 0.657, option B is 0.765, option C is 0.567, option D is 0.776. I have already given you the formula. Just go to the formula and see if you can solve it. Just try for yourself, and if you can't, then I will be doing the new. I will be solving the.
Sir, is it third option?
Yes, sir. It is 0.567.
0.567. Yes, it is correct. The answer is 0.567. Sorry, 0. Third option. Sorry, 0. Yeah, 567. Yes, correct answer 0.567. Okay, let me just. Yeah, can you hear me? Hello. Yeah, the
Yes, sir.
correct option is option C. So let me. You people have got it right. So just people those who couldn't solve it, let me just do it for them. So the equation is fx equal to e to the power minus x minus x. So if we find the first derivative of this f x minus e to the power minus x 1. Just give me 1 second. So according to Newton Raphson, x minus e to the Now for this, if we put different values of x, zero, so already right. For 1, if we take 1, it will be 0.5042. For second iteration, it will be 0.5663. For third iteration, it will be 0.567, and for fourth, 0.57. So yes, the answer is 0.567. So the correct option is option C, 0. Yeah, okay, so option is option C, 0.567. Next, let me go to the next question. In blank, a sample is placed in a vessel and is progressively heated to 550 degrees Celsius under an inert atmosphere. During the analysis, the hydrocarbons already present in the sample are volatilized at a moderate temperature. So, which of these analysis, in which of these analysis a sample is placed in a vessel and is progressively heated to 550 degrees Celsius under an inert atmosphere? The options are option A, vitrinite reflectance, option B, rock eval pyrolysis, option C, calorific value, and option D, none of these.
Sir, option B, rock eval pyrolysis.
Option B, rock eval pyrolysis. Anyone else? Okay, so yes, the answer is option B, rock eval pyrolysis. Next is next is Organization of Petroleum Exporting Countries OPEC was founded in 1960 in option A Vienna, option B Baghdad, option C Tehran, option D Riyadh. We have already done this in today's class. So tell me the answer.
Sir, option B, Baghdad.
Option B, Baghdad. Anyone else? Okay, so yes, it is option B, Baghdad. Next is, which of the following is a type of offshore rig? Option A is drill ship, option B is semi-submersible, option C is drilling barge, option D is all the above. Anyone else? Vishal had said all the above. Anyone else? Sayed? Yeah, Sayed. Any guesses?
Sir, I think C.
C, drilling barge. Okay.
Yeah.
Okay, so the correct option is all the above. Option D. Vishal was right. It is all the above. So we go to another question. Question 9. The For a function fx, the values of the function in the interval 0, 1 are given in the table below. Write this table. So the question, I am not, just give me 1 second. Yeah, can you see my slides? You see my slides, right?
Yes.
Okay, so after writing this equation, so the value of the integral limit 0 to 1 fx dx according to the trapezoidal rule is option 1 1.8, option B 2.0, option C 2.4 and option D 3.1. Try this numerical.
Sir, option 1, 1.8.
Option 1 1.8. Yeah, anyone else?
Sir, option A.
Option A 1.8. Okay. Yeah, the correct option is option A 1.8. Very good. So let me just solve it for others if someone couldn't do it. So yeah, let me first write the trapezoidal rule. That is h equal to plus 5. The values are already given. So give h equal to 0. Let me take the table for 0. 4 0 5 6 6 1 6 If you don't understand my handwriting, please let me know. See, my handwriting is not one of the finest. So if you don't understand any of my writing, just let me know. So 0.2 plus 3, y naught plus yn is 2 plus 6, 0.96, 2.4. So 4, 8. So 1.8 is the answer. Okay, you people have already done it, but still. So yeah, and we come to the last question. So the process of conversion of trapped organic matter in a subsurface into kerogen is called option A diagenesis, option B catagenesis, option B metamorphosis, option D hydrolysis. Any guesses? Yeah, Vishal is saying option A. Anyone else?
Option A, sir.
Option A. Yeah. Anyone else? Yeah. So the correct the option is option A diagenesis. So yes, the option is option A diagenesis. So yeah, so that's all from the assignment. So this week's assignment. Next week again we'll be meeting on Tuesday and we'll be doing week 2 assignment. And hopefully we in week 2 we'll be getting more numericals. I want to do some numericals with you, so that so you people are from everyone is from BTech or MTech, and can you let me know what are you studying right now? Yeah, Vishal, you are from BTech, chemical engineering, MSc chemistry. Anyone from chemical engineering background? Petroleum engineering background? Chemical. And college? BTech mechanical. Okay. So no one from petroleum engineering background. BTech petrochemical technology. Okay. BTech petrochemical technology. Okay, so yeah, I am BTech chemical engineering from Puducherry. Okay. So yeah, there see I have seen many people have registered for the course. If you have any WhatsApp group or you are in contact with other people who are attending this course, let them know there is this about this online session, interactive session in which we can discuss about other questions also. It's not that the questions that we are facing that I am solving in the class, we need to discuss those only. If you have other doubts relating the subject related to your course, any doubt regarding any numericals, you can ask me. Maybe in the same class, maybe I can give you means solve the questions. If not, if I have other numericals to do, but if you give me the question, I can solve it by myself and give you the answer in the next class, in the upcoming class. So yes, just uh, just tell others to be present in this class. Hopefully it will be helpful, because this NPTEL videos you see it's pre-recorded, so it's not possible to ask doubts every time. although there is a interactive session with the professor of the course also, but still, yes, this is a weekly session. Any doubt you have, anything you have, you can just ask in this session. We can solve the assignments, and if we have time we can go through a doubts, and if not, I will solve it by myself and give you the answer, or we can discuss in the upcoming class. Try to attend it in a way that you can prepare for gate if you are planning to give gate in petroleum engineering. I myself have given gate in petroleum engineering, so it will be easy for me if you take the same approach to guide you if you are planning to give this gate exam in petroleum engineering. So there are PSUs like ONGC and IOCL. They recruit from petroleum engineering, and also in petroleum engineering the rush is little less than chemical engineering, so it will be a good options for those who are in petroleum and who are in chemical engineering. Even nowadays you can take two subjects for gate. You can do side by side this subject also if you are interested. And yes, okay, so that's all for today. And yeah, tell others to join if you are in contact with the other people taking the class. I hope to see some more students in the next class. That will help to gain interest for me also for teaching. Okay. Okay then. Good night. See you next Tuesday. Same time at 7 p.m. Thank you, Mohammed. Thank you, Avni.
Thank you, sir.
Yeah. Thank you, Syed. Thank you, Vishal. Thank you. Thank you. Thank you. Good night.